From time to time, we may need to run some slow Python functions with a timeout, so they can be under control and won't crash the whole system by accident. There are various ways to do this in Python. We will introduce how to do it using concurrent.futures, multiprocessing, and async I/O, and compare their different behaviors and application scenarios. We can use a thread to run the function and utilize concurrent.futures to handle the timeout. Concurrent.futures is a modern library to work with threads in Python. We will first write a simple sleep function that sleeps for specified seconds. Then we will run this function using the thread pool executor from the concurrent.futures library. Especially, the result method returns the result of the call that the future represents. If a timeout is specified, a timeout error will be raised if the function doesn't finish executing before the given timeout. When we run the script, we will see these logs. A strange behavior is that the function continued to run after it timed out. This may or may not be what you want depending on your practical use cases. The reason for this behavior is that the Python threading model does not provide a built-in way to forcibly terminate a thread once it has started. The thread will continue running in the background even though the main program has moved on due to the timeout. To stop the execution of the function after it times out, we can use the multiprocessing module instead. We can use the multiprocessing module instead of concurrent.futures to run the function in a separate process. Unlike threads, processes can be forcibly terminated, which allows us to stop a function when it times out. Note that unlike in the script where concurrent.futures is used, we need to run the functions using if name equals main. Otherwise, a runtime error will be raised. This is because there would be some conflicts between the main process and subprocesses if the functions are run directly. When this script is run, the function will be stopped if it times out. If you're working with asynchronous code, you can use the async I/O library to handle timeouts. Note that we need to use async io.sleep to sleep now, and need to await it. Otherwise, it won't work properly. Besides, the functions should be executed with async io.run, and we should not await them there. When this script is run, the function will also be stopped if it times out. In this video, we introduced various ways to run functions with a timeout in Python. We need to use multiprocessing and async I/O to run functions with a timeout if they need to be stopped when they time out for synchronous and asynchronous code, respectively. However, since multiprocessing is more resource-intensive than threading, it would be more efficient to use concurrent.futures if your functions don't need to be stopped when they time out in synchronous coding scenarios. This is it for this video. Thank you for watching. If you enjoyed the video, please subscribe to my channel for more content. As a senior software developer, I'm passionate about sharing my thoughts, tutorials, and solutions to promote best practices in software development. See you in the next video.